Have you ever wondered if the condoms you use are truly safe? Do manufacturers test each one individually or just pick a few at random from an entire batch? And what happens to those that don't meet the standards? The answer might surprise you. Let's journey back in time with Captain Discovery to the origins of the pristine white latex flowing silently in deep forests, the beginning of the condom production process. If you find this information fascinating, don't forget to like and support the video. As dawn breaks, farmers prepare for a day's work. Razor-sharp knives are carefully sharpened, ready for harvesting latex. With skilled strokes, they make precise cuts into the bark of rubber trees, allowing the white latex to flow into small cups securely fastened to the tree trunks. After a night of collection, the cups are full, and farmers carefully gather them, pouring the contents into large buckets. Before the latex is ready for production, it must be treated to prevent solidification. The process is simple yet effective. Ammonia is added to keep the latex in a liquid state. At the factory, raw latex undergoes strict quality control. Only approved batches are poured into large vats and mixed with ingredients like tamil, casein, and zinc oxide in an ammonia solution. This mixture is stirred continuously for 5 hours to achieve smoothness and uniformity. It's then aged at 60 degrees Celsius for 5 days to stabilize before moving to the critical stage, product molding. Glass molds, polished to a mirror-like finish, are repeatedly dipped into the latex mixture. thin, even layers coat the molds, forming the initial shape of the condom. After the dipping process, the molds don't go straight to drying. Instead, they pass through an automated rolling system where the soft latex edges are carefully rolled into the distinctive ring at the condom's opening. This small detail plays a crucial role in ensuring a snug fit during use. And you might be surprised, the initial shape after dipping looks just like the nipple of a baby bottle. An interesting coincidence. Either you use a condom for prevention, or you'll end up using a baby bottle as a parent. Once the ring is shaped, the molds move to an automated demolding system. High-pressure water jets gently release the condoms from the molds without tearing or deforming them. Meanwhile, the glass molds are cleaned in an automated system, dried, and prepped for the next production cycle. But the journey doesn't end here. The condom's production process is only halfway complete. Condoms are then treated with a softening solution to maintain elasticity. They are then washed in large machines with water and special chemicals. Next, a dusting of anti-stick powder ensures they won't stick together during use. The condoms, after being thoroughly cleaned, are transferred to a drying oven at a temperature of 90 degrees Celsius. This process hardens and sets the shape of the product while also removing excess moisture. At the testing phase, do you think each condom is inspected individually or are only a few selected randomly? The answer is both. Some are manually checked, but the majority are tested using highly advanced automation systems. One standout test is inflation. Condoms are inflated like giant balloons until they burst under pressure. And what happens to those that fail? Beyond inflation, condoms are also tested for leaks by filling them with water. They are squeezed, rolled, and manipulated to detect any holes. Their tensile strength is also checked. Each condom must stretch to over 750% of its original width. Any failure results in immediate rejection. Finally, the perfect condoms are lubricated and packed in specialized packaging. Modern factories can produce over 1 million condoms daily, meeting the global demand of 10 billion annually. These astounding numbers underscore the critical role condoms play in public health protection. If condoms are the protective shields of health, then lubricants are the companions that ensure smooth experiences. Have you ever wondered how lubricants are made? Are they truly safe for sensitive skin and overall health? Let's dive into the production process of lubricants. Lubricants are made from familiar ingredients: purified water, glycerin, and natural extracts like aloe vera. But the water isn't ordinary. It's filtered through multiple layers to ensure it's free of impurities. Ingredients like glycerin, which retains moisture, and aloe vera, which soothes the skin, are rigorously tested before use. Everything is then blended in a large mixing tank where a powerful agitator ensures the ingredients combine into a consistent gel. But there's more. To achieve a silky smooth texture, the gel is filtered again to remove any fine particles or unwanted air bubbles. This meticulous process creates the luxurious feel of the product. Surprisingly, lubricants aren't just about slippery. Each product undergoes stringent safety checks, including pH testing to ensure it's compatible with sensitive skin and won't cause irritation. This critical step guarantees safety, especially for intimate areas. Once approved, the lubricant is transferred to automated packaging lines. Pre-cleaned bottles are filled with precise amounts of gel, sealed tightly and securely capped to prevent contamination. Modern factories produce 2 to 5 million lubricant bottles monthly, catering to a global market worth over $1 billion annually. Beyond being just a product, lubricants enhance comfort, safety, and happiness in daily life. While lubricants ensure smooth experiences, pregnancy test kits provide certainty and unexpected joy. How can a tiny device deliver accurate results with just a drop of urine? Let's explore its production process. Pregnancy test kits function by detecting the presence of the hormone HCG in urine, a hormone produced during the early stages of pregnancy. The presence of HCG is identified by special antibodies embedded within the test. These antibodies are designed to bind specifically to HCG, enabling the test to display results. But how does the test strip, the core component of a pregnancy test kit, achieve this task? The test strip is where the chemical reactions that detect HCG occur. Made of cellulose or nitrocellulose, the strip effectively absorbs and channels urine through its structure. To detect HCG and display results, the strip is divided into 3 key regions, each performing a vital role. 1. Reaction zone. This is where the process begins. The reaction zone contains the first set of antibodies designed to recognize and bind to HCG in the urine. As the urine flows through this area, if HCG is present, the antibodies capture it and transport it to the next region. 2. Test zone. In this region, the captured HCG binds with a second set of antibodies. This process forms a sandwich-like structure and triggers an enzyme that produces a visible colored line. This line is a crucial indicator of a positive result. If no HCG is present, no line will appear in this region. 3. Control zone. Regardless of whether HCG is present or not, urine activates antibodies in the control zone, generating a colored line. This line ensures that the test is functioning properly, allowing users to confirm the accuracy of the test. Once the test strip is complete, how is the sterility of the pregnancy test kit maintained? The answer lies in the next steps. After completing the test strip, the next step involves assembling it with a protective casing. The casing is made from medical-grade, non-toxic plastic and is designed for safe and easy use. The test strip is carefully placed inside the molded plastic casing, which includes components like a protective cap for the urine absorption tip and a handle for user convenience and hygiene. The process doesn't stop there. Random samples of the test kits are selected for quality checks. These tests include sensitivity testing, using urine samples with varying levels of HCG to ensure accurate detection. Durability testing, evaluating the test resistance to heat and physical stress to confirm stability during transportation and storage. Result validation. Each test must display correct results for positive, negative, or error conditions to verify product reliability. Once the quality checks are passed, the test kits are sealed in aluminum or waterproof plastic packaging to protect them from moisture, light, and contamination. The packaging ensures the product remains sterile until use. The final step includes adding user instructions, labeling with batch numbers and expiration dates, and preparing the product for distribution to the market, guaranteeing it reaches consumers in optimal condition. Which of these products surprised you the most with its production process? Share your thoughts and reasons. Regardless of the product, they all face a significant challenge: environmental sustainability. Manufacturing these items generates waste, from raw materials to packaging. However, many modern producers are adopting eco-friendly measures, such as using recycled materials, optimizing production lines to minimize emissions, and designing biodegradable packaging. Protecting human health is crucial, but so is safeguarding our planet, don't you agree? Condoms, lubricants, and pregnancy tests. Each product carries fascinating stories of technology and innovation. From raw materials to finished goods, all undergo rigorous processes to ensure the highest standards of safety and quality. If you're curious about how other everyday products are made, let us know in the comments. Don't forget to subscribe to Captain Discovery to stay updated on more intriguing content. See you on our next adventure.